like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody! So we are live right now. Well, everything should be good. We're doing a little bit of a new setup here, so you might see me looking a little bit more to this way. So we've got everything set up in a little bit better way, so it actually looks like I'm talking to you. And we've done some adjustments. So we've done some improvements. Hey Eric, hey Jason, everybody. Bailey's present, Megan. So good to see everybody. And just, you can always tell us if the audio volumes are good. I'm gonna turn myself up just a tiny bit there. You can tell me if we start getting a little bit of clipping sound in here. But with this in mind, we're gonna cut over to Jason now to see how Jason's doing. Jason, how are you doing?
What's up? What's up? Sitting here, just checking it out. Hello.
We'll cut back here, but we're always trying to improve this stream here, everybody. We want to make it look even better. We've done a bunch of good improvements to what we have going on here. You'll see them throughout today. Basically, we wanted to do some improvements. You can see here when I cut to, we have, my audio should stay with that, but we've now got some fun, neat stuff right here. Also, when I point, I should be able to point that way. Oh, it's this way now. I don't know which, oh, I didn't reverse the camera on this one. This one still has the camera the other way. I gotta reverse the camera and I gotta move over here a little bit. So what was on the wall? Jason, they want to know what's on the wall. What's on the wall? He doesn't know. Okay, so we're back. We got some good streaming stuff going on. But you know what? That's the theme of today. I gotta look at my buttons here. Does anyone know what today's lecture is? Can you tell from what's over there? What today? Hey Anna, hey Nicole, hey everybody. Caleb's saying hey in the chat. That transition though. So guess what today is? You guys don't like this. Today is randomness. We just got, it's all about randomness today. So today is all about that randomness. That's all you're gonna be seeing going on today. We got some randomness going on right here. Wolves, wolves everywhere.
I like wolves.
So randomness. So thank you everyone for being here. We're gonna pull up the lecture right here. So the biggest thing, I want to point this out. With this, everyone's 1,000 points randomness in the chat right there. And if you notice, I am looking more up here now when we're doing the chat. We've got the camera and everything set a little bit higher, so I'm looking a little more forward. If we can get the video to 70 likes, can we? I'll give you 1,000 bonus points for just suggesting that. I won't make you guys like the video for us to get points. If you want to give it a like, that's fine. And if we get to 70 likes, that'd be awesome. No bonus points on the likes. That way it's not like I'm contingent on giving you points on whether or not we get likes, but you can do that. So I was impressed with this student with his musical talents. Oh, thank you guys. Thank you guys. Just sat down, play a little piano. Always like playing piano. It's fun little relaxer before the exam. Play a little, what did I play? Pirates of the Caribbean. That's one of my favorite songs. I think what else I played, but sit down and play some piano. Just nice and relaxed. Just enjoy your time. Thank you, Josh. So points, points, points everywhere. But the big thing that I want to point out is with the exam, I can't play Crab Rave on the piano. I wish I could. With the exam having just happened, do not forget to do your assignments. Do not forget that all of the assignments are going to be due here. Do not skip them. A lot of these quizzes are a little tricky. The assignments get less and less and less as the semester goes on and on and on. So you will have less assignments, but they'll be a little more difficult. So it's good to see you, Mohammed, everyone here. So what's going on? Jason, would you like to tell them the theme of today? What is the theme of today?
Randomness.
Thank you, Jason. That is the word of the day here. We're just having too much fun with those transitions. So, and thank you for everyone who always gives us suggestions on what we can do. We want this to look like one of the best streams out there, and that's what we're going for. So, we've got right here, boom, randomness, right into the lectures. So, what I want to point out is, this is not that bad of a chapter, and they're asking about the test averages. Right now, I think we're at a 79 average. We've got a lot graded, and we're just like the other classes because we're doing some tests on it. I've seen some 97s and 96s. And the projects are getting graded. If there's an issue with your project grade, please talk to us. But high C, low B is not bad. That means if you're following along really well, you probably got a B plus or an A minus. That doesn't mean you got that. Maybe you're not following along well and you got a good grade like a B plus or an A minus. but 79-ish is pretty good with where we're at. And I looked at some grades, and one thing I noticed was there were some lower grades where people kind of trailed off on Chapter 5, Chapter 6, Chapter 7, and Chapter 8. I haven't seen 100 yet, and I really want to see it. The test grades are skewed to the left. The test grades are skewed to the left, like you've got this left skew distribution where it's built up around the maybe 70s and 80s, and then skewed to the left. We'll keep hoping that someone gets that 100, and I'd love for that to be you guys right there, you and you and you, and you all get hundreds. But the biggest thing, I don't know who's been graded. Oh, Ronald, he's saying we haven't graded his yet. Nice job, Ronald. We'll hope for that. So the biggest thing is this. When I was looking at people who were successful and people who weren't successful, a lot of it was normal curve, a lot of it was regression. And I want to point this out. I always make bets on what we're going to teach, and I'll make some bets today on what we're going to have on the test on randomness. Now, I'm not trying to teach the test, but I mean, it kind of helps if I'm like, hey, this is a pretty likely thing on the test. So when I'm suggesting things today, like, oh, you should know how to do this, like when QQ is straight enough, no outliers, plot doesn't thicken, I was mentioning that weeks before the test came out. When we were talking about for each 1 unit increase in x, we expect y to increase by b1, or when x is equal to 0, we expect y to equal b0, or blank percent of the variation in y is explained by the variation in x. All of these things were on the test, and I was kind of making bets, not that I only teach the things we should know, but I was like, we need to know this. 1,000 points, Alex right there. QQ straight up, no outliers, plot doesn't thicken. So today I'm going to be doing the same thing. When you see me going over something repeatedly, that's something you should know. So please take notes. When I'm talking about randomness and how it works, remember those things. So have your notebook out. Who has their notebook out? 1,000 points if you tell me you have your notebook out. Who has their notebook out? We're gonna have we'll put a little music on for do you have your notebook out? Here we go. Do you have your notebook out right now? Anna's first person, 5,000 points. Anna, Chase, 1,000 points. All those people. Oh my gosh, look at all the people with their notebook out. Have your notebook out. So we hop right in here to randomness. I love it. I can hear it on Jason's mic over there. So random dancing. I love it. Like Jason said, he likes wolves. That is pretty random there, Jason. So here we are in the randomness chapter. What all does randomness mean? Well, people always tell me that random events really don't mean anything. It's like, well, what does it mean for something to be random? Does that mean they're all equally likely? Winning the lottery is random. Random means you do not know what will happen. So with that in mind, is winning the lottery like 50% probability you win, 50% probability you lose? That kind of, tell me in the chat, is that really how random events work, that they're 50-50, that all random events? Jason and I would be going out after this and buying lottery tickets if it was all 50-50 random. So Chris says no for 1,000 points. Thank you, Chris, right there. Chimes in first, and I like that, because it would not be random. It doesn't have to be random to be 50-50, or reverse that. It doesn't have to be 50-50 to be random. 0.001, Nicole, I like that right there, is basically impossible. So what does random mean? When we say something's random, we might have an understanding of it. We might say when you roll a dice, getting 1 is random. What's the probability of getting 1 when you roll a dice? You roll a dice, what's the probability you get 1 when you roll that dice? Does anyone have any idea? I mean, it's random. 1 in 6 right there to Carolyn and Taylor, 1,000 points, and also Natasha and Madeline. It's random when you roll a dice, but it doesn't mean we don't have a way of talking about those probabilities. We can't predict what can happen, but we can assign probabilities to those events. So that's why statisticians use randomness as a tool. Randomness is very important to us because we can understand these probabilities and use them. We don't think of it as something like scary. We're not like, oh, that's random. We can't understand that. We would say, this is random. We can utilize this. Depends on how many times you do landing on the randomness. I agree with that. Remember, if you thank you, Jason. Jason's always helping out in that chat right there. Every time you buy a lottery ticket, your chances of winning doesn't increase. Alexis, good life advice. 1,000 points to Alexis right there. You could, if you bought every lottery ticket number, you would win, but then you'd spend like, I think like $216 million, I think it is. I think it's like 1 in 216 million to win the lottery. It might even be less than that, but then you'd have to win the lottery on your own, and then after taxes, you'd have to take that amount. So it's not a good choice. That's Brian's life advice. Oh, someone disliked it. Oh, that means we got to get more likes to imbalance that if you want. So yeah, it does help education. So what do we do here with randomness? Well, what we do is we can do a simulation, We also can talk about when we take a representative sample. So what we want with randomness right here is to take a representative sample from a large population, and we can do this a lot of times with a simulation. And so here's the biggest thing. Representative samples are what we're going to be covering very soon. And the people still got to come by my office hours to pick up their Starbucks gift cards. So if you won, or if your friends won, tell them to swing by. The biggest thing is we need to know what a simulation is. That is huge. This is basically this whole chapter. And we're going to do some really cool stuff at the end right here. But this chapter right here is all about simulations and how we can use randomness to perform simulations. Like our project. Wait, I'm so confused. What about the project? So let's look at a simulation right here. We're gonna have some more fun with this because sometimes I find these slides a little bit dry. But think about this. We could do a simulation of a 75% free throw shooter, and so here's the probability they make their free throw. Could you do this with coins? So I want you to imagine you have 2 coins, which we'll look at in a second here. What could you assign to these coins? Like how could you, imagine you have these coins in your hands. Well, what if the person was a 50-50 free throw shooter? If it's tails, that'd be make it, and heads would be miss it. So they're saying, yes, Eric for 1,000 points in the chat, and Adriana, 1,000 points. They're saying you could use these. How would we do a 75% free throw shooter? Well, how about we assign this one right here is that they miss it, and these would be that they make it. So now we have 3 outcomes. If you notice there's 3 down here, let's do a nice 3 right there. There's 3 outcomes down there, and there's 1 outcome out here. So if you look at the way this simulation is done, you have only 3 out of the 4 outcomes, or I shouldn't say only, I should say 1 out of the 4 only where they miss it, and 3 out of the 4 they make it. So if one of your favorite basketball players is a 75% free throw shooter, just take 2 coins in your hands, shake them up and drop them, and you can simulate them shooting a free throw. So that's what we can do to do this, but it'll get more exciting here in a moment. We can look at the distribution of this, and it'd make a normal curve. You'd actually be shocked that a lot of what we're looking at is normally distributed data. So we can do this and actually model this, and this will be coming up in later chapters. So this chapter is a very important yet fun chapter. We're about to have some fun here in a second, where we can do simulations. So I want you to say in the chat right again now, what is the point of using randomness? How do statisticians use randomness? Statisticians use randomness as a tool to perform what? That keyword for 5,000 points, first person who gets it. It's the thing that we've been saying all throughout this chapter. Statisticians use randomness as a tool. I'll take as a tool for 1,000. Who's got it? Simulation from B-Show right there, 5,000 points. Thank you very much. Statisticians use randomness as a tool to perform simulations. So if you're taking simulations in the chat, 1,000 points. Using representative samples to make simulations, exactly Anna, another 1,000 to Anna on top of the 1,000. But the important thing we need to know is that randomness isn't bad. Randomness is very good. Randomness. So with this in mind, there are some times where randomness is hard to figure out, it's hard to incorporate. It's very hard to simulate things like an election is even hard to simulate. But we have people like Nate Silver who actually simulate elections and get decent results on what might happen in an election, and they just simulate the election to say what might happen. The more realistic we make it, the more realistic our outcomes. And with this in mind, we're going to hop down here. We're going to talk about the last few things. I actually kind of disagree with this because I think as computers are getting better and better, we have a lot of things that we can simulate. Like we can simulate a jet, we can simulate a baseball game, we can simulate so many things that people thought were too complex. So are there things that are too complex? Maybe, but there's a lot of things we can simulate. So with this in mind, we're going to talk about a simulation right here and have fun with it. One thing we can do is random number generation. We're right about to get to the big meat of this lecture where we have some fun. So what we have here is a random number generator. Can anyone tell me, with a random number generator, how could I simulate a dice roll? For 1,000 points, what could I put into this random number generator right here to simulate a dice roll? Any ideas of what I could put in there? Min of 1, that's the 1,000 points right there, a min of 1, and a max of 6, there you go. Now if I put this into the random number generator, 1,000 points, all those people, that'll simulate a dice roll. Well, I can't simulate heads and tails though, because if I go over here and try to simulate heads and tails with this, I can't put in H or T. How could I simulate, this is all simulation right here, how I could simulate heads and tails on dice. How could I do that with this number generator thing? How could I simulate random, like dice rolls? I mean, not dice rolls, but heads and tails. They're doing it. So I think it was Alex first for 5,000 points, all those remaining answers. There you go. Now with a min of 1 and a max of 2, we're simulating a coin flip. So 1 through 6 would be a dice roll. 2 through 6 would be a coin flip. You could simulate whether or not you should take one of your friends out to dinner. You'd be like, let's see here, who should we take? And you could do friend 1 or friend 2. All these things right here are things we can simulate right here, and we can just put in these random numbers. Now it goes without saying you have random number generators and you have random number tables. So you'll see here random number tables with just a whole bunch of random numbers, and you can just pick from the random numbers. So it'll just have random numbers listed out. What we're basically talking about here is how your homework assignments look and how the test questions might look. On the test, you might have random numbers like this, because we can't have you simulate them. Have you sent out an email about getting the 20,000 points? Yes, and hopefully we don't lose everybody at 520. Did we just lose everyone to go? Jason will tell me if we lose everyone on the stream. So this chapter is not a long chapter. The point of it is to get us right here. And if you're still in the chat, we're about to play an even bigger game than that 20,000 points. We're about to do a simulation. And 134, that is awesome. Another 1,000 points to everyone in the chat. Thank you everyone for being here. Because Jason, get excited Jason, because Jason knows of this game. Who in chat has ever heard of The Price is Right? Let's see, let's go to Jason. Jason, whoops, that's randomness button.
Oh, definitely. Price is Right. It's awesome. Bob Barker. Who is it now?
Drew Carey.
Yeah, it's Drew Carey now. Yeah. I just showed my age.
So let's hop over here to the screen. And so we got it right here. We got the screen right here with the price. You said this isn't The Price is Right? Yes, it is. It is The Price is Right. You know, I need to be a bigger host right here. So Brian's gonna be, there we go, look at that. So it's probably too big. Let's go a bit smaller here. Giant. So like I'm all looking excited over there. Like there we go. So I like the Dracula. They like it. So Jason is supposed to be you. Jason's just here. He's the director guy. They like your art piece, Jason. So here's what we're gonna do. We're gonna play The Price is Right, and some people are gonna be able to get some mega points. So I want you to notice one key word throughout this. Here we are. I am losing my mind. Where is it? There we are. Cool, I couldn't see the button. Do the extra credit points matter since we're playing Drew Carey game? Oh no, yes it does. It does matter. So this is actually how statisticians use randomness in a lot of ways. I want everyone to take a look at the line right here. On The Price is Right, the wheel goes from what to what? What does The Price is Right wheel go from? Jason might have to help us out here. For 1,000 points, who in the chat knows The Price is Right wheel goes from blank to blank? Does anyone know? Not 1 through 100, not 1 through 100. Oh, close. 5 through 100 and 1,000 points right there. 5 through 100 in units of 5. And if you notice right there, that is sampling from a sequence of 5 through 100. You don't have to know coding for this class. You don't have to know coding. But how many times might you be able to spin the wheel? You might be able to spin the wheel up to how many times? Do they know in the chat? How many times might you be able to spin the wheel? You might be able to spin it 2 times. Nice job, Daniel in the chat for 1,000 points, and so is Sydney. So let's see, who wants to play The Price is Right? Who's the first people to say me? And my gosh, the chat's probably gonna flow with everyone saying me. So I wonder if they're gonna hear the sounds in the chat for this. So okay, we got The Price is Right loaded in now. Okay, I gotta scroll up. The first 2 people to say me was Emily, and so we're gonna go here, we're gonna put you guys in the chat. We're gonna play 3 people. And this is all randomness right here. We're gonna play 3 people in The Price is Right. And we have Emily. And we had Natasha. I shouldn't scroll up. Natasha. And we have Taven. Jason, you're going to play the next game. We're going to get you in on it. Oh, did I click the wrong button? I clicked it. There we go. Emily, you are up to spin the wheel. Now let me explain the rules here. You are spinning the wheel for a number 5 through 100. You do not want to go over 100. You can't do that in one spin. So if you get Eric, you might be next. You'll just have to join Eric. Say me. Eric will get you in on a game. So you are spinning the wheel, And this is random. Whatever you get is random. Remember that. We're going to simulate the prices right here. Josh will throw you in too. Eric, Josh. Maybe we'll have the guys around next. So we'll have Josh, Eric, and we'll have Jason. I forgot your name for a second, Jason. So Emily, you need to spin the wheel here. And if you win this, there'll be some mega points. I'll announce the prizes here. Emily, spin the wheel. What does Emily spin on the wheel? I'm hoping someone gets a really good score. Emily hasn't spun the wheel. Spin it! Oh my gosh. Jason, did that? This is random. I love it. Guys, I did not cheat. I did not. This is no cheating right here. Emily just spun a 100. Emily, do you want to spin again or no? Hey, wait.
Don't do it.
Hey, wait, Jason, we got to ask you. So, wait, does that, am I clicking, I clicked the wrong button. Here, we got to go to you. Jason, what's your advice?
Do not spin. Do not spin.
All right, Emily chooses not to spin again. Okay, Natasha, spin that wheel. So we'll spin the wheel for Natasha right here. So here goes Natasha. Natasha, Emily has 100. You have 55. You want to spin it again? I'm assuming yes. And Emily's gonna spin it again. Here we go. Or Natasha, sorry. Natasha spins again. Oh no! Oh no, no, no. Jason's making the sound effects for us. No, Natasha, you're overspun. Emily has no idea how it works, but she won. So Emily, the goal is, and we're gonna spin for Taven here, and then Taven got a 55 also. That's so crazy. This is all random. So the goal is to get as close as Natasha in the chat. And Taven, do you want to spin it again? Oh, Daniel asks a really good question. I do not know, Daniel. That's a really good question. She's gonna spin again. And so here we go right here. Don't worry about that warning with beep R message, but Taven overspun also. So let's explain. So everyone gets 10,000 for playing. Emily gets 20,000 for winning. And we're gonna have a showdown of the final winners here. So we have Eric and Josh, but I want everyone to understand what we're doing here and why we do this. If you remember anything from this lecture, what are you noticing here? Brian is simulating the prices right here, which is you get to spin the wheel and you try to get as close as you can to 100 without going over. And the goal is that this simulation is mimicking reality as best we can. So this is a statistician as much as I am, and this is code I created right here to write out the prices right and have it spin the wheel, and hopefully you guys win. So let's do another round of it, and we're gonna do some more work here in practice. So here we go. We got 3 players here. I think it was Jason, we'll have you go last. We had Eric, and I think it was Josh. Was it Josh wanted to play? Jacob, you might be in. Was it Josh or someone else said me? Get Ronald in this, Brian. We'll do one more round of this. We're gonna do one more round. You guys gotta be quick. We got Jacob, and then here we go with Jason. Okay, Eric, spin the wheel. Get ready. So it was Sam. Eric spins the wheel and he gets a 50. So you don't want to get over 100. Eric, do you want to spin again? Josh, there you are. Josh, you're on next. We'll do one more round of this. Round of champions. Eric spins again and gets 120. Jacob, spin the wheel. Jacob, spin the wheel. We need someone else to get some mega points right here. Jacob, spin the wheel. Oh, we're going to spin the wheel for Jacob. Oh my gosh. I wish we could hear the sounds when it happens too. Jacob, do you want to spin again? We're going to the phone friend again to see if we need to. You're competing against him.
Do not spin.
You're competing against
Do
him.
not spin.
Jason's a good guy. He's helping you guys out there. How does this? It's random. He said spin. So he said spin right here. So yes. Is that a yes? Are we doing yes? Oh, we're doing no. I feel like someone will get mad at me if I said yes. Jason, we gotta hop over to Jason. Probably too much, but I'll do it. Jason, spin the wheel. You gotta spin it. Spin it.
And spin.
There we go. Oh, I hopped to the wrong screen. Jason's gonna spin the wheel here. I'll stay over here. Jason spins the wheel. 95.
Yeah.
Well, he got 100. He got 100. What do you have to do if he has 100 and you have 95? Jason? Should we cut to you?
Wait. I think I see a 95.
Yeah, but he has 100.
Oh. So
They're telling you in the chat to spin again.
To spin.
Yeah.
I have to go for a 5.
And Jason,
Oh, man.
you got a 50. That would have been so awesome. First person in the chat, 10,000 points. What was the probability that Jason would tie him? What was the probability Jason would tie him? What's the first person, 10,000 points. What's the probability Jason would tie him? Ooh, are they going to know it? They're saying, I'll take that. It's actually 5 because it's 1 in 20. There's 20 numbers on the wheel. If you answer that in the chat, you get the 10,000 points. We're throwing some big points right there. But there's 20 numbers on the wheel. It's basically 5, 10, 15, 20, 25, 30. So there's 20 numbers, and there's a 5% chance he would tie him. And I wish that would happen right there. So okay, I'm gonna play against. I think we said Jacob wanted to play. Was it Jacob? Am I getting the names right? You got to be quick. Who said they wanted to play? 10,000 points if you play. Serena says she wants to play, and I think it was Jacob. Am I missing you? I'm missing their name. Everyone's saying me. I love it. And then Ronald, you tagged me. Ronald, that did it. And then Brian. Jacob already played. I think it was Josh. Okay, Brian. Okay, Serena spins the wheel and she gets an 85. Serena, what are you gonna do, Serena? What are you gonna do, Serena? Any ideas? Serena is going to, this is a big thing. Serena, spin again or no? She says no. Okay, Ronald. Ronald got a 20. What are you gonna do, Ronald? Ronald, are you gonna spin again or no? Everyone in the chat, you need to tell them what to do. Ronald, tag me if you want, but chat, tell them what to do. Spin again. Spin again. Ronald spins again. Oh, okay, now it's my turn. You ready? Got big here. 80, but wait. Serena's got an 85. Should I just forfeit? Which chat thing I should do? 1,000 points if you tell me what to do in chat. They're saying spin, spin, spin. Dang. Spin again. Oh wait, I almost typed no. That was actually an accident. Who won? Who won? Don't take me on. I got this. There you go. That's random. Oh, it is playing the music, right? Can you hear the music in the chat, the Final Fantasy Happy music? Yeah, the sound effects, I put those in. Those sound effects are coming from right here in the code. It's an if statement for those who like doing code. And so, are we on ultra low latency today? I hope we're on a really quick low latency. Jason, does it seem like we're on ultra low latency? Because I might have done the latency too high. You might. Oh no, we might be on a 15-second delay today. Sorry everyone if there's a delay. I've kind of noticed that when I ask something it's a little slower, I might not have clicked ultra low latency. Hey, the video will be better quality though. So, winning The Price is Right is in my blood. It is. My brother won The Price is Right. You guys remember that. That was a suspicious win. Well, okay, to clear that out, are we on ultra low latency, Jason, or you think we're on?
Seems like it, yeah.
Okay, good. So to clear that out, let's hop back over here to the lecture session. And what we're going to do now is we are going to help you guys with your homework. A lot of people get stuck on the homework, so let's get some awesome grades on the homework. Do you guys want to practice some of this material right now with the homework and see how randomness works? How does that sound? We've seen some examples of randomness. We've seen how people use randomness, and now we are going to do some homework, and we can probably get a lot of your homework done. Do people want to do the homework or the quiz? And I bet you we can complete maybe even all of it, if not a lot of it. So that was kind of my goal for today, is to show you exactly what we're doing with randomness, and then to give you insight about how the test would look. So what you just witnessed there was key examples of randomness in action. That is, do what? 8-second delay?
Yeah.
So that is randomness in action. And now let's take a look. Are they saying the homework or the quiz? Let me see what people want. And let me bring back up Streamlabs. Both. I see a lot of quiz. Oh yes, I like that. People are saying yes, let's do it. So let me hop back over here. So some transitions, but that's our first one right there. If you guys liked it, we are keeping it. So we're gonna hop over here to the quiz, and let's go here to replace questions. This will allow me to do as many as we can. Okay. Wait, this is chapter 8. No more chapter 8. I was like, why is regression on there? That was random. So let's scroll down here to replace questions. We're going to do as many randomness questions as we can. Hopefully I don't get any wrong. Let's find out. Okay. So with this in mind, I'm going to shrink down just a little bit so I'm not blocking any of these questions. But let's take a look right here. Can we do randomness in jump? Yeah, you can. You can simulate randomness in jump. I was using R to simulate my randomness. You can do randomness in many different programs. R can generate random numbers, both. I like that right there. So the more difficult one. Flipping a fair coin is said to randomly generate heads and tails with equal probabilities. Explain what random means. What does random mean? Don't even look at the answers. Random means we can't predict what will happen. And I think this one gets a little tricky. In the long run, a fair coin will generate exactly 50-50 heads and tails, but for each coin flip, the outcome cannot be predicted. In the long run, a fair coin will generate 50% heads and 50% tails approximately, but for any specific coin flip, the outcome cannot be predicted if all previous coin flips results are known. So it doesn't even matter if we know them or don't. In the long run, a fair coin, people are saying A, in the long run, a fair coin will generate 50% heads and 50% tails approximately, but for each coin flip, the outcome cannot be predicted. Man, is everyone saying A? Everyone's saying A, and I'm a little iffy on this one. Randomness, I wouldn't love this as a test question because, one, we're going to get to something here in a moment, the law of large numbers. The law of large numbers will be in the next chapter. The law of large numbers states the following about a 50-50 coin flip, is that if you have a 50-50 coin flip, the probability of it being heads and tails is 50% if in the long run it approaches 50%. So that is the law of large numbers. That's a horrible 50%. Ignore that. But the law of large numbers states that the probability in the long run of an event will be seen. People are saying D now. So it might be D. I'm leaning towards D. I just don't like the way sometimes Mike Pearson phrases stuff. Let me look at the wrong answers. But for any specific coin flip, the outcome can only be predicted if all previous coin flips are known. No. So B and C are ridiculously wrong. You can't, if it's random, you don't know what's going to happen if you know past events. It's not saying, then it wouldn't be random. That would mean it's not random. So the difference between A and D is that this is where I don't like it. Because the end of it is completely right. Each coin flip cannot be predicted. And I remember doing this one with a student last semester. I was like, oh, come on. So, my inclination, the law of large numbers states that a fair coin in the long run will generate that. So, oh man, I'm so between. People are saying D. Let's see what it is. Got it. That's what I thought it was. Because here's where I had a qualm with it. If you notice what I drew out right here, and so this is good for you guys. Remember, you can see the answer now. It depends on how long of a long run is considered exactly. Because if you talk to infinity, as you approach infinity, it would generate, like, infinity is not a real number, but if you were to approach infinity, this would go to 0.50. So that's the issue, is theoretically speaking. I remember saying that to a student. So I was like, I remember saying, like, this is how it works theoretically, and then being like, well, if the long run is infinite, which is not a real number, but it just works that the limit would approach 0.50. So it would be approximate, like in the long run, like anything we would consider naturally, but for the infinite trials, you would see that. So we can understand, and understand what this means. It goes back to what we said earlier, that we understand a fair coin in the long run would give us 50% heads and 50% tails, but each coin flip we don't know the outcome of. When you flip a coin, you don't know the outcome of it because it's random, but you can associate probabilities with it. So take that note. Random means you don't know the outcome of an event, but you can still associate probabilities with it based on knowledge you have. And that would be knowledge of observing things. Like if you would say, imagine I'm getting picked up from school from my parents, and my parents are late 20% of the time. Could I do a simulation to see if my parents picked me up late? I would just generate a number between what and what. And there's a few ways to do it, which some of these questions we'll get to. So to see if my parents would pick me up late, there's a 20% probability, generate a number between what and what to see if they pick me up late. Who can figure that out? If you know what I'm saying here, you are exactly on track with us right now. All you'd have to do is generate a number between 1 and 5, Adriana, 1,000 points right there. 1 and 5, and you could assign 1 to be your parents pick you up late. So we can actually do this. These are just quick and easy simulations to understand how they work. Is you could go here and just go to random.org, and let's take a look. And we go to the random number generator right here. And we generate a random number between 1 and 5. If it's 1, my parents picked me up late. And yeah, woo! Parents were on time picking me up. So you can just do the generating of random numbers right there. Parents were late. So this just generates random numbers, and you can simulate things like, did your parents pick you up late? So all of this right here, random.org. Thank you very much, everyone in the chat. So great answers. Keep those answers coming. Watch how we do these randomness questions. So this is just the definition of randomness. Make sure you have the definition of randomness down. I've definitely seen that on the test. Like, what does it mean for something to be random? And it's like, it's a 50-50 probability. If it's a coin, but not if it's a dice roll, not if it's your parents picking you up late. There's lots of things that are not 50-50 probabilities for randomness. Here we go, this is a fun one. So for this one, we're gonna make it really big on the text because we need to see these numbers. What we have right here is a student who is going to be assigned to do a project on a state. So students will have to figure out which state they're doing, and then they will be assigned. Now, how many states are there? Let's see that. What is the chance that you flip a coin 10 times? It'll land on heads every time. Great question in the chat. Probability is, there are 50 states. There's to the Eric. Eric, that's your answer to your question. That's the probability it will land on heads 10 times. That's a chapter coming up. So there are 50 states. So only the numbers 0, 1 through 5, 0 will be used in this simulation. So what do you notice right here? What is the state that the first student will be assigned? The first student will be assigned what state? And sorry I can't highlight it, but look at the numbers in here. The first student will be assigned state what? Like the first student will be assigned what state? 28. And then what other state will they be assigned? They'll be assigned what other state? What other state would be good to be assigned? I think I didn't hit ultra latency today. Oh, and you guys might have it. I see some interesting answers in the chat. Now I want you to look at this. 28, 86, 26. Okay, let's hop over to here. 28, the numbers on the screen were, let me delete that. Oop. Numbers were 28, 82, and 26. So what you have to do is you have to break them down into 2 number chunks. So what is the 82nd state? There is not. There's not an 82nd state, so we have to skip that one because there's not an 82nd state. Does everyone understand that? And we can't use the 8 because it's 2-digit combos. And so the answer is they'll be assigned the what state. You skip that number right there, they'll be assigned the what number state. They'll be assigned the 26th state. Nice job, 1,000 points. All those people giving the answer right there. Keep those answers coming. This is good practice for the test. So that student will get the 26th state. How did we know that? Let's take a look at how we knew that. Well, going down here, you'll see that the first 2 numbers are 28, 86, 26. Then what's the next number? What will the second student get? The second student will get, nice job, glad you see that, Eric, there, 1,000 points. They'll get 1, so we'll type 01. But here's the thing. What state do they get after 01? And be careful. After 01, they get what? After 01, it says they should get, what does it say? Now, I know you might have already figured it out. I'm looking at the next one too. Oh, you guys already figured it out. So it says they should get 26, but we already have this person getting 26. So we would skip this right here, and they would get state 02. So they get like Alabama and Arkansas, maybe Alabama, Alaska, something like that. And I think that's almost answered this question. Is that it? We got it. Does everyone understand how we did that? That's a little tricky, but think about it as this. You can't choose a number outside of 0, 1 through 50. Nice job, those people in the chat. So you can't choose a number outside of 0, 1, 50, and then if someone has the state, you can't repeat it. Now, I want to point to something. Simone, I'm throwing 1,000 points, and keep asking those questions because I see all the things in the chat. If you have a question, always tag me. It makes it real easy to see if you're like, I am stuck on this. Every simulation has rules. So here's big test tips. Every simulation has rules. The rules for this simulation is as follows. Students will get 2 states. States are numbered 0, 1 through 50. So let's write them out right here. The rules for this simulation are, rule number 1, you get 2 states. Rule number 2, 0, 1 through 5, 0 are the states. So the only states that can exist are 0, 1 through 5, 0. Kind of conditional. The probabilities change. It's dependent probabilities. So it's kind of conditional because that's dependent distributions. Great answers, Daniel, 1,000 points. The last rule is no repeats. So the rules for that simulation are every student gets 2 states. The states are numbered 0, 1 through 5, 0. And so let's write another rule here. Skip 51 plus. So if something's 51 plus, you skip it. And then you must always look at it in a 2-digit combo. So if you see 08, that's 08. The only way to get 08 is 08. So does everyone understand these rules right here? If there's a number like 51 or 84 or 62, you skip it. Students cannot repeat the same state that they get. Students get states 0, 1 through 5, 0, and every student gets 2 states. If you know the rules of a simulation, you can do the simulation. Just like the simulation I wrote had rules, you need to think about the rules you have for the simulation on the test. This is the big thing. Here's test tips. When you get to the test, look at the simulation, understand the rules. If you're confused, ask me about them. Be like, hey Brian, what are we supposed to do for this? I mean, I can't tell you the answer, but if you're like, wait, are we supposed to like skip these numbers? Or are we supposed to, and I'll be like, probably like, oh, look, here it says this. Know the rules for each simulation. Let's hop back into doing the questions here. Wait, we already got it. There we go. It's like, where's the answer? Oh, this is a fun one, I think. This is you go to a test and you have no idea how to answer the test. So we're going to copy these numbers right here, and let's figure out how the rule goes. So did it copy it interestingly? Oh my gosh. Okay. So what we have here is each trial, and I should be able to write on this screen. So the rules of this simulation is as follows. You have an 80% chance of getting a question right. And I believe the numbers, let's look at the numbers. Getting a question right are numbers what through what. Rule number 1, a question you get correct is numbers what through what. Who can tell me in the chat for 1,000 points? Questions you get correct, 0 through 7, Courtney, 1,000 points, and Carolyn, and Anna. Numbers or answers you get wrong are numbers, Megan, I'm throwing 1,000 points too. Thank you everyone in the chat. So the answers are, if you get something wrong, it's a number 8 through 9. If you get something correct, it's a number 0 through 7. So what you're taking is a 6-question multiple choice, and you want to see that you get them all correct. So I want us to pretend. Every time you do a simulation, you're going to pretend it's happening in front of you. So let's look at these numbers and pretend we're taking the test. Who here would be happy with the first test? Tell me about how you feel about that first test. Who here can see the first test? And let's mark on it. Who here is happy with that first test? So down this pathway, here we'll do it a different color. This is the trial right here, so that 1 does not represent, oh my gosh, what have I done? There we go. So this is where the trials are at, and everything to the right of it. Who here would be happy with that first? They're good. They're happy with it? That'd be good. How did you do, Anna, on the 6 questions? How did you do? How did we do on that first test? That first test, when we took 6 questions, what happened? 5 out of 6. So let's circle this one right here. That's the one we got wrong. So we missed 1. Nice job. So 5 out of 6 right, 1 wrong. How about that second test? Uh-oh. This one doesn't look as good. We made a 66, it looks like. How'd it go on that second test? There we go. Third test. Does everyone see what I'm doing here? Is I'm marking how many I get wrong. Wait, is 9 right or wrong? Like when I took the question, I made a 9 on it. Does that mean I made a 9? That means I got the question, it's bad, Eric. 1,000 points right there, it's bad. Thank you in the chat. And if you notice, these are bad, so tell me if I miss a number, it's a little bit bad of a circle right there. Oh my gosh, am I ever going to ace the test? Wait a minute. What just happened on trial 12? What do you notice about the numbers on trial 12? The numbers on trial 12 are all what? You missed one on the third test? 10,000 points. Oh my gosh. Thank you very much. 10,000 points. Jennifer and other people saying you missed one on the third test. You caught my error. So I passed the test. More than passed, I aced it. So what we're going to do is we're going to put a highlighter across this right here. I aced that test. And then we have miss and miss. All you're doing is pretending. Oh, what? Whoa. Wow. This can happen. I am only circling those just to see where I got them wrong. Great question, Carolyn, for 1,000 points. I'm kind of just keeping track where I get things wrong so I can see that there's at least one question wrong. So you dropped the ball at 15. I totally dropped. Hey, but 16, how does that test 16 look? Pretty good. And then we go here and there we go. Now I want to point this out. If you notice what I've done here, this is kind of what you might do on the test. Now I have no idea what the test will look like, but if you look at the practice test, this looks a lot like it. So the numbers greater than the diagram is what's wrong. The numbers greater than, or numbers 8 and 9 are assigned to getting them wrong. Basically, we're pretending for the moment that we have a 80% chance of getting any question on the test correct, an 80% chance of getting any test question correct. So we're simulating as though we hand, because imagine, if you study for a test and you would make an 80 just randomly, it's possible that you could make like a 33. You could just have a really bad test. No. So that's why I've had people get a bad test. This is such a good question. I had a student who told me, they were like, I was salutatorian and they made like a 66 on the first test and they were freaking out. They were like, I've never made a D. And I was like, well, you probably just had a bad test. And we looked over it and they just made a few small mistakes. They just kind of flipped things around and they're like, oh, I can't believe I said that. I knew that. And so on the next two tests, they made like a 94 and a 98 and they did fine. They actually made an A in the class and they made a D on the first test. It's very possible that you can have a very smart student who just has a bad test. So it's unlikely, but it can happen. So I hope you get 100. I hope so too. I want to see 100. I love it when people get hundreds. How many times out of the 20 trials did someone get a perfect test? How many times out of the 20 trials did someone get a perfect test? Was it Eric? 3. So the answer is 3 divided by 20, which is 15%. So be following along and be practicing with me here because we're going to get these assignments really done well. Oh, this is the fun one. So, wait a minute, it was 7. Oh, okay, so here we go. I'm about to hit that randomness button again. I don't think it'll show up here though. I don't have it loaded into this area. I can't do the randomness. Okay, so this one right here is a tough one. This is one that I added in about 5 years ago that everyone hates. But I'm going to show you the best way to do it. Please get ready for this. Get ready for how to solve this one very quickly. Is everyone ready? I'm going to throw the pen on the ground. That's good. Apparently I wasn't ready. So, oh no. So what we're going to do is we're going to take these numbers and this is what you have to do. Please note what I've done. I've highlighted through the numbers. For some reason, my Pearson almost doesn't want you to copy these numbers. I have a video where I do this and I go through it. Please note I am copying these numbers with Control-C and I'm going to bring them over to Word. Can I erase everything? I can. Now here's the craziest thing. When you copy them into Word, they will double copy. Remember this video is recorded so you can see how I'm doing this. What you're noticing here is these numbers have copied twice, which I have no idea why, but for some reason when you copy them from my Pearson, they will copy twice. And the way to find out where they copied twice is to hit Control-F and to type in the numbers you see at the start, and you see where the numbers copied twice, where they start to repeat. Delete those numbers off. Because it just, I don't know why, it's something just, the way it does it, delete those numbers. Now you have a second line of numbers down here which have also copied twice for some reason. Like I said, I have no idea why. It's just the way it is. It's sad. So let's go ahead and delete these extra numbers here, but we have to find 2, 3, 8, 1, 4, 4. There's a delete button for a reason. That's why. There's just for that reason there's a delete button. Does everyone see that what I've highlighted is just a repeat of that series of numbers? There's no reason for this. It's just my person doing this. That's the only reason. So now, guess what we've done? And let me show you, I think I can control Y, yes I can. So if you notice here, here's your numbers to start. That's the first group where I have to delete the duplicates, and then I delete the second group of duplicates. So here's what you get to start. Delete the first group of duplicates, delete the second group of duplicates, and I'm doing it in this video, so you can rewind it, and I also have a video where I do this question too. So now what we're gonna do is we're actually gonna start working with this. Has anyone ever played the game Sorry? We haven't talked to Jason a little bit here. Jason.
Oh yeah, play it all the time.
Play all the time.
Oh yeah.
Got Dracula there.
Yep.
Dracula over there. So with this, we'll hop back over here to playing Sorry. So here's how you play the game of Sorry. You will be.
Oh man.
It is random day. It's random day. It's complete random day. Just trying to keep everyone on their toes. When you play the game of Sorry, you can be 10 spaces away from the goal. It's about 10 spaces. So with these 10 spaces you're away from the goal, you need to roll the dice. You want to get home. What would happen if you were right here? What would you have to roll right there to get home? That's where you're at. What could you roll to get home in that instance? 1. Everyone's saying 1 for 1,000 points right there. You need a 1. They're saying, I need a 1. You don't want a 1. You need a 1. You would need a 1 and 1,000 points extra on top of that right there for you. You are right. You would need a 1. So here's the thing. What if someone rolls a 5? Can you do that? How many spaces do you move when you roll a 5? 1, 2, 3, 4, 5, 6, 7, 8. We need 2 more spaces here. You can't. You move 0 spaces. So here we are. What we're going to do is we're going to simulate a dice roll, but we can't simulate it yet. We're going to start out 10 spaces away such that we have to move 10 spaces. But what numbers do dice have on them? Like a normal dice. What numbers do normal dice have? It should be under Find and Replace. One through 6. So let's replace 0 with nothing. Does everyone see the zeros go away? Let's replace 7 with nothing. Let's replace 8 with nothing. Let's replace 9 with nothing. If you notice, I'm under here under Control F or Command F. I think you can hit Control F on a Mac or Command F on a PC, and there'll be a little down window that will pull up on the Mac. You'll see a little down arrow. But you should be able to click on the thing right here after Control F or Command F. And you should be able to go to Find and Replace, and you should be able to remove the numbers. This is the easiest way to play the game. So does everyone see what we've done here? Don't try to delete them yourself. You'll click the wrong button. All I did was find my 9s, my 7s. So if you look at it in reverse, you can see the numbers start to appear. I deleted the 0s. I deleted the 7s, the 8s, the 9s, and there we go. So now we only have dice rolls. What does everyone think about this portion? Does this look weird right here? Does that look weird right there? It's random. Randomness can do that. Jason's got the random song going. It does look weird, but it's random. You see a bunch of interesting things if you look at patterns for too long. Eric says no. Eric thinks that looks fine. I like that right there. Eric's like, yeah, it's just fine. It's random. That's what randomness does. If you look at it for too much, you're like, that's not random. It's random. So with this right here, let's go and play the game. Here's how the game is played. We are going to move as many spaces as we have right here. So how many spaces am I moving to start? How many spaces will I move on my first dice roll? I roll the dice. Now you have to imagine, Brian rolls the dice and he moves 1 space. So now we go and we move our 1 space forward. So there's our 1 space. Brian rolls the dice again, and then he moves 5 spaces. So we'll put the 1 right here. So now we go 1, 2, 3, 4, 1, 2, 3, 4, 5. I think that's it. Hopefully I drew this board out correctly. So now I'm over here. So if you think about it, I am now 6 spaces into the game. If you look, you can actually see it. We'll put a mark on this. How many spaces, just look at it visually, how many spaces does Brian have to move to get home now? I moved 6 spaces total. How many spaces do I move? Serena's got a good answer right there, and so does Ronald. 1,000 points, all those answers in the chat. I have to move 4 spaces. So when I roll the 6 right here, we could put a 6, and we could put an X on it. So 6, I spun 6 next, but I can't use it. But then I spin a what? Or I drop a what? I roll a, you're probably saying in the chat, I roll a 4. So 1, 2, 3, 4. How many turns did it take me in playing the game? Now you're probably answering 4 right now because that's the right answer and you can see it. I was not able to use that 6 right there, but I was able to do it. So we're going to hit enter, and that was 1 game. In that 1 game, it took me 4 trials. Now this one's really interesting. This is a pretty weird pattern right here on this next one. So let's play the sorry game again, and let's see it right here. Boop, delete that off. Go away. There we go, perfect. So now we're going to start all the way back here. What do we roll to begin this time? What do we roll this time? We roll a what? We roll a 3. So 1, 2, 3. Then we roll a what? Another 3. So we roll another 3. 1, 2. I don't know why I can't count today. 3. It's because they're not evenly spaced. And then we roll a what? A 3. So now we're rolling 1, 2, 3. And now what do we have to roll to get home? What do you notice we have to roll? We have to roll a, oh geez. Then we roll a 6, then we roll a 3, then we roll a 3, then we roll a 4, then a 6, then a 5, then a 4. Wow. Has anyone ever had that happen? Like you're about to win the game and you just can't win the game, you're just stuck? That was horrible. Just imagine this happening. Imagine, this is a simulation of reality. Anna, 1,000 points right there. Anna's had this happen. Go home. I know we finally got home. Yep, Kate, another 1,000 points, so did Eric. But we've had this happen where we can't win a game. And then you go and you get a backwards card. No! And you still need to get the right amount to get home. Sorry, Taven. Sorry, 1,000 points to help out with that loss right there. So we're going to speed this up because we can imagine this. I want you to say in your head, this is the way to do it now. I want you to say with me as you repeat these numbers, I want you to keep track of the total. But if the total goes over 10, we're going to say over. So I'm going to hit the right button and we're going to say 4. So right now you should say 4. So in the chat, be saying 4. Because if you notice where I'm at with my cursor, you'd be like 4. That's where we're at. We're at 4 spaces. We move 4 spaces. Then I move it over 1 more, and we're at how many? We go from 4 to what? Like 4, Courtney right there, 1,000 points. Now we're at 8. All we're doing is just adding them up. But here's the thing, now this is where it gets tricky. When we move to the next one, what should we say? Remember, this is too much, so what are we going to say? We're going to say this is what? I said the word earlier, 1,000 points, who's got it? Over. Over, Ronald, nice answer. And then 3 is over, and then 1 is 9. And then once we get to 9, what do we have to go to? Once we get to 9, what do we have to go to? We have to go to, once you get to 9, you have to go to a 1. So here we are with 4, and then 9. Now we have to go to a 1, because the only thing that can get you home is a 1. 1, 4, 10. 5, 9, 10. 1, 5, 7, 8, 10. Please tell me if I make a mistake. 2, 5, 6, 10, 4, 7, over, 10, 4, 7, 8, 9, 10. Delete the extra numbers. I sped up there at the end. It's just the same thing over and over again. If you get the way the game works, the game has the following rules. We are dropping a dice which has numbers 1 through 6 on it. You cannot go over. You have to roll 10 spaces forward, and you have to make sure you don't go over. Those are the rules of this game. So if you follow those rules, you will get something like this. Now you should have, if we break it up into parts, 5 here and 5 here. Probably easiest way. This means we've played the game correctly, and we have 10 total trials. Since we have 10 trials, I can go down here and click the words button, and I can get the answer. If you notice there's 72, it's probably hard to see, but that says 72 total. There are 72 total characters on the screen right here. So that means there's 72 dice rolls. Divide that by 10, and the answer will be 7.2. I did 10 trials. These are each trials. And when you do trials, you're just doing a simulation. Each simulation can have a trial. Now we're going to take another huge note right here. I want to see this in the chat for 1,000 points. How can you make a simulation better? How can you make it more accurate with its probabilities? To make a simulation more accurate, we could increase its what? To figure out a better simulation, increase its what? To be a more accurate simulation, increase its, have this note in your notebook, to make a simulation more accurate in the probabilities it's figuring out, increase the number of more trials. Anna, 1,000 points right there. Trials, big one right there, trials. Nice job, Anna. So it's that trials word I was saying earlier, because what you could do is you could keep doing this simulation with more trials and get a more accurate probability from it. This is trial 1, this is trial 2, trial 3, 4, 5, 6, 7, 8, 9, 10, and you could go all the way down here and do like 100 trials, and that would give a more accurate simulation. It makes it a more accurate simulation. Of course, your rules need to be accurate, but the numbers you get out of your simulation will be more accurate with more trials. Huge note right there. To make a simulation more accurate, increase the number of trials. Please have that written down. To make a simulation more accurate, increase the number of trials. Jessica, 10,000 points. That is the perfect note that you should have in your notebook right there regarding simulations and trials. So the answer to this one is, and did I miss a question? I think I might have missed one. Let me take a look back here in 2 seconds. The answer here is 7.2. Let's hope I did not lose a number. Take a deep breath. Woo! That one's a scary one. That one is so easy to make a mistake on. Very easy. Oh, we get the next hardest one. Fun times. At least this one will be on video now. I'm taking those points. I like that right there. Serena, there's another 1,000 for you. How can you make a simulation better? You can increase the number of trials. I like that right there. Serena, 10,000 points also. I'll give you the ones. Make a simulation more accurate by increasing the number of trials. Courtney also. 10,000 to Courtney, Serena, and Jessica. Perfect notes for your notebook. Have those things written down. This one is also one of the hardest. I'm glad we're encountering these ones. It's probably my least favorite problem on the whole thing. So let's do this. Let's do my least favorite one. So what we have here is people going to a grocery store. You have to imagine these things. Every time I talk about a simulation, it's imagination. Just do that. We need the meme, Jason. We need that right there. I should just have a rainbow appear. We could make that happen, but we didn't prepare that for today. It would have been so cool if I had done that and it just like appeared, but no. So with this in mind, you have to imagine you go into a grocery store and they're going to give you money. That sounds cool. So if you get a number 0 through 5, it's like they hand you a card, and that card is a certain amount of money. If it's 0 through 5, you get 20 bucks. 6 through 7, you get 50 bucks. 8, 100, 9, $200. Now this grocery store wants to give away a lot of money to a lot of people, but they don't want everyone to get all the money. So they want to know what's going to happen if they do 10 trials. They are going to give away money until they've given away more than $400. I like that, Kate, 1,000 points right there. They're going to give away money until they give away more than $400. So if the grocery store has given away $400, would they stop or keep giving away money? If they've given away $400, would they stop or give away more money? We can make that happen for you right here. If a grocery store has given away $400, would they stop or give away more money? If they've given away $400, they would keep going. That's a trick to this one that a lot of people get caught in. If they give away 400, because they need to give away more than 400. So Taven, 1,000 points right there. We caught everyone else. But here's the big thing. Don't worry if you got caught on that. You don't want to get caught on it because it's a trap that you could hit on the assignment. So make sure you notice the keys right here, that they're going to give away more than $400. So let's take a look right here. Let's run the simulation. This is another tough one right here. And it might be, let's go here to comma. And this is like my least favorite one, Jason, of all time. I'm responsible for this question too, I think. This is one of like the longest ones to solve. It takes 5 minutes even if you're solving it quickly. I know, right? Yeah. So what we need is we need a cheat sheet on here. We need 0 through 5 represents, I think, $20. And we also need that 6 through 7, I think, is $50. There it is. Cool. Let me go back here. And then 8 is $100. and then 9 is $200. So you can do this with replacing the numbers. Give away more money. I like that right there. What do you notice about this 5 right here? This 5 is going to be 20, 20. If you make one mistake in here, you're done. That's what's really not fun about this question. That's why I was like, this is one of my, I'm going to do it because a lot of people hate it, and hopefully I don't make a mistake. But if you need to memorize what the numbers are, or keep them in your head, but we're going to scroll down until we can see a little bit more. I think I know them pretty well enough now. This is 50. This is $20. Oops, you see I'm going to make a mistake right there. This is $20. We're turning these away from the values they are to the values they represent, and hopefully I don't make a single mistake right here, or it's game over. If someone's like, wait, you made a mistake, I'm hoping no one says I make a mistake. That'd be pretty bad. It'll wreck the simulation. That's an 8. 8 is $100. Happy them. And there's another $100. And so we're getting pretty good into the simulation right now. If you notice, these do not represent numbers. They represent how much money people get. It's the important thing to note about simulations is that we're simulating reality right here. This person walked in, got $20. Man, people are not having a good time in our grocery store. They keep getting $20. I don't like it. That makes the simulation longer. I think my person actually gave me one of the worst ones possible. Finally, some people down there, that 9, that is a happy day for them. They walked in and made $200. This person got 100, 20, and this person got 200. Got to not make an error. 20, 20, 50. And I'll explain briefly. Someone might be asking in the chat, what are you doing? This is 20. This is 50. Let's go back to playing The Price is Right. That's more fun than this. Oh, we're almost done. Where's the end of this? Surely the numbers end soon. And then I'm probably going to make one error, and if you make one mistake, you lose the question. If I have you guys do the assignment, I'll do it also. We are almost done with the recoding. Oh my gosh. When does this end, Jason?
It's a nightmare. It just keeps going.
I know, right? I think Jason's logged in right now. He's copy pasting numbers at the end.
No escape.
Just I feel like Jason, let's hop over to Jason now while Brian recodes the data. Jason's gonna end real quick.
There's no escape.
There's no escape.
This is still going.
It's still going?
Yeah.
Jason is falling asleep here.
It's rough.
Jason's falling asleep?
It's rough. Whew. Man. The numbers just keep going.
Just Jason. I've completely lost my mind over here too. So let me get serious. Oh my gosh. This is like least top favorite questions. And I watch me have made a mistake as I'm slowly losing my mind. We will not put a test question this oh my, really? Then you throw the laptop. Did you just put a 7? Oh no, they're saying did I put a 7 as 100? 7, oh I did, didn't I? Oh my gosh, 10,000 points. I did, I thought of that too. Was it this 7 right here? That should be a 50. That would destroy the simulation maybe. Chase and also Adriana. Thank you both. So, so that's the 100. Oh my gosh. Thank you all for catching that. I was just seeing if you're paying attention. Jason was fast asleep over there, but we got this. I mean, I'm asleep too, but oh my gosh, we got Justin High. There's another 7. Is it over? Is it over? Are we there yet? You ever hear that in the car, Jason?
Oh yeah. Plenty of times.
See, nowadays, you just be like, pull up Waze. Waze will tell you if we're there yet. You say, has the car stopped? Nope. I didn't think this one was that long on the numbers. Oh, there we go. Okay, we will finish class with this question, and then you'll get to see it. Audio is as high as we can without distortion. Does anyone think? I think the audio is good. Yeah, I turned it up a good bit. I think.
Oh, you did?
Yeah.
Just recently?
I turned it up a little bit recently.
Okay, great.
I'll give myself another little bulb, another jolt, and there we go. I raised it a little bit.
Right there, yeah.
Yeah,
Okay,
I'm pretty close on it.
Okay, cool.
Yeah, Jason, they are You are the man, Jason.
I saw something about the audio. I woke up.
You, Jason woke up. Audio? We got that.
Yeah.
Okay, so here we go. We can do more. I'm giving a test at 6:30 in 15 minutes. So I know we will start next class probably with an example or two. So this is some of the hardest questions. We've literally covered the two hardest ones, I would say. The rest are pretty easier simulations. Here's the thing, know the rules of your simulation. The rule of this simulation is these random numbers represent dollar amount, which I've coded right here. And unless I've made an error, then everything's coded properly. You can do it with control find, and I probably should have done that. You just make sure you find and replace exactly the numbers, because when you recode with the ones and the twos, things will crazily happen. So recode your numbers and then play the simulation. The rule of the simulation is now we have to give away more than $400. More than $400. That's key to this. So we've given away 20, 40, 240, 260, 310, 330, 350, 450. That is trial number one. Now we've given away, oh my gosh, this is insanity. We've given away 100, 120, 170, 220, 240. Let me make sure I have this. 100, 120, 170, 220, 240, 260, 280, 300, 320, 340, 360, 380, and there it is right there. That's more than enough. Now we've given away 20, 40, 60, 160, 260, 310, 330, 350, 370. Wow, person broke the bank. Oh, wow. Oh, geez. 20, 40, 60, 80, 100, 120, 140, 160, 180, 380, and there it is, 480 right there. I'm basically adding up these numbers right now, and then when I get more than 200, oh my God, I agree. 220, 220, 240, 260, 260, 310, 330, 350, and this is 400, so now that's the one that ends it. Oh wow, I just scrolled up all the way to the bottom. Yeah, I know, right? 100, 120, 320, 340, 360, 380. I'm gonna make sure I'm gonna check this one again real quick. 100, 120, 320, 340, 360, 380. It's easier when you can see the numbers. Like my brain just works better when I can actually see them. And we're almost done. We're in the home stretch now on this, of the second part of it. 20, 70, 90, 110, 130, 150, 170, 190, 210, and then we go there, so that's got that. Scroll down, let me see the numbers. 20, 40, 90, 110, 130, 150, 200, 220, 240, 290, 310, and that's it right there. We're almost done. This is 100, 120, 170, 220, 240, 260, 280, 330, 350, 370, 420. And look at that. Nice and easy on that one. And this might be one last simulation. So 50, 20, 70, 270, 290, 310, 330, 350, 370, 390. Now it looks like this is not a final simulation. We should have 10 simulations right here. So now let's check to see if we have 10 simulations. We'll be ending here in just a second. So let's see here. This is simulation number 1. This is simulation number 2. I'm gonna try to write left-handed. This is about to be bad. Simulation number 2. Simulation number 3. Simulation number 4. Simulation number 5, number 6, number 7, number 8, number 9, and number 10. It's got it. So I think it wants the total amount of trials it took. We just did 10 simulations of giving away at least more than $400. So this one right here is pretty crazy. It is easily the one that takes the most time to do. The average number of winners each week. So what we have to do is we have to add up the winners in each group. This group had 3 winners. This group had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 winners. So you know what we can do? I think we can just click the words button. There's 94 total words, and there's 103 lines. So if it's counting all of those as a word, fingers crossed. With 94 total words, we should get here that there are 9.4 on average. And that'll do it, and that'll free us, and I'll be running over to the exam here. So we should have 9.4. Woo! That one scared me. I hope I peeked there a little bit. So, oh my gosh, that scared me, guys. I was like, please tell me I got that correct. I think I actually got one of the worst possible versions of that. There's 9.2, 8.6, 8.4. That's one of the highest I've ever seen in the 9s, 9.6. So 10.2, oh my gosh, glad we didn't get that version. But that's how you do this one, which is one of the hardest ones. This one's an easy one. There's a lot of easier ones once you know the trick. That's probably the next most difficult one. So next class, we'll probably do this one right here. Do this though. Do the homework and attempt the quiz. Then next class come and be like, hey Brian, do this question, and we will start with those questions that you're stuck on. Does everyone feel like they understand that all we're doing here is we're using random numbers and doing simulations with them to simulate reality? Like this is people playing a game. So this is all we're doing is we're using random numbers to do simulations to mimic reality. Randomness is a tool, and it means we don't know what's going to happen, but we can use the associated probabilities with it. But try the homework, try the quiz, and practice, because it'll really help. A lot of the test questions are focused on a simulation or concepts around simulations, such that randomness is a tool that statisticians use to mimic reality, or we can increase the trials to get a more accurate simulation, or, what else is it? Randomness is not a 50-50 probability. It's associated with the probability of the events. But that's got it. I'm going to run off to the exam. We're going to do some more review next time to start, and we'll start another fun chapter. So let's hop back over here. You know, we got to make it fun to end it. We just got to end with a little randomness. But this has got it. Last but not least, what was that over there? I think I heard something coming from the side of the room.
Random! It's random.